Hello everyone and welcome back to our discussion, no? And this time we will be having the third method of solving a first order first degree differential equation. So this time we have the exact differential equation. So if we try to recall, the first one is a VSDE, the second one is a homogeneous differential equation, and the third is an exact differential equation. Now, first, we have to know when can we say that the differential equation is exact. Now, this is the definition and this is the condition for exactness. Now, writing your DA to follow a general form of a first order, first degree differential equation. No? So, you can start with a dx term followed with a dy term. Right side is equated to 0. So, this is exact if the partial derivative of the coefficient of the dx, okay, the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. So, ang coefficient sa dy, adto nimo i-differentiate sa x. Ang coefficient sa dx, adto nimo i-differentiate partially with respect to y. And if the results are equal, then we can say that the dA is exact. So, we have some samples on how to test for the exactness of the dA. Now, we are given a dA written to follow a general form, okay? Now, we have m, and what is our m? The coefficient of the dx. So, in this case, we have 6x plus y squared. Now, I'm going to differentiate the coefficient of the dx or the coefficient m of the dx with respect to y. So, differentiating partially with respect to y, so the variable x here is considered as a constant. Thus, the first term, it is free from y, which means this 6x term is a pure constant term, the derivative of which is 0. Y squared, and you will be differentiating with respect to y, so this is equal to 2y as its derivative. Okay? So, in the coefficient of the dy, so your n is equal to 2xy minus, this is 3y squared. Now, differentiate this partially with respect to x. Now, so the first term is composed of xy. No? So, the constant factor here is 2y. No? So, it is placed before the operator, and the function which will be subjected to differentiation is the function which will contain the variable of differentiation. So, this is differentiated and the derivative of this is 1. So, entirely, so this is 2y times 1. The derivative of your first term is 2y. The second term, if the differentiation is done partially with x, then it is free from x. That would mean this is a pure constant term. Its derivative is 0. Now, note that the function in y is constant. Now, since these two partial derivatives have the same results, then we can conclude that our dA is an exact dA. To gain more familiarization, we have another example. If I have a cosine 2y minus 3y squared minus 3x squared y squared, the coefficient of the dx which is your m, then I have to differentiate my m partially with respect to y. So, the cosine 2y is a function in y, so it must be placed after my operator, which means this is to be subjected to differentiation process. In my second term, now, if that is differentiated with respect to y, the factor of minus 3x squared is a constant, so it is placed before the operator. What is to be subjected to differentiation is only the y squared. What is the derivative of a cosine u? It is minus sine u du dx. So, the derivative of 2y is 2. Okay? Now, this one, y squared, the derivative of y squared is 2y. So, all in all, you have a derivative which is minus 2 sine 2y minus 6x squared y. Then, I can go with the coefficient of the dy, which is called as n. Okay? So, the cosine of 2y minus 2x sine 2y minus 2x cube y. No? So, will be differentiated partially with respect to x. Cosine 2y does not involve x. No? So, it is 0. Kine, it contains a function in y. Okay? And a function in x. The differentiation is done with x. No? So, the derivative of x is 1. No? With respect to x. So, the derivative of the second term is minus 2 sine of 2y. Dire, so x cubed will be differentiated to y's constant. So x cubed becomes 3x squared. So all in all, we have a derivative which are actually equal. Now, therefore, it is observed that the given in number 2 is also an exact differential equation. Now, after we know that the dA is exact, no? So, how to proceed finding the solution of a differential equation. So we are given steps here to follow. So the first that we did in example 1 and 2 already follows the step 1. No? So after knowing it is exact, we can proceed with step 2. We solve for f. No? So by integrating partially these two equations. Okay? So from the coefficient of the dx, so we can integrate with the x partially. Okay? Unknown function is considered the function in y because y is considered as constant. Okay? Then we can have the second term. We integrate partially also with respect to y. Then x is considered as a constant. Then we can include an unknown function involving x. Then determine the unknown function f of x and g of y from the result of 2. Then number 4, our f. Now, f is equal to a function containing xy. So this function will actually appear on both f obtained or equation here obtained out from 2. Now then we can add the purely x function, unknown function in x, and the unknown function in y, f in a. Then we can have the solution where we collect the terms from f and we equate that to c. And that is the solution or general solution of your exact differential equation. So here is a particular example. We are given example number 1. Okay? Since we do not know yet that this, whether it is exact or not, then we have to subject that to test. Okay? So we have test for exactness. Okay? This is m and this is your n. So what's your m? My m is y squared, di ba? Minus 2xy plus 6x. When you differentiate this partially with respect to y squared becomes 2y. Y with respect to y is 1. Now, when you differentiate, what is left is the constant factor minus 2x. 6x does not involve y. The variable of differentiation is y. The derivative of this is 0. Now, if this is an exact dA, then the coefficient of the dy, which is n, okay, which is a minus x squared plus 2xy minus 2, will also produce the same derivative if it is true that this is an exact differential equation. Okay? Differentiating n partially with respect to x. This is negative 2x. Kine, this is 1. 2y is left. So it's 2y. This is constant. Okay? So that means that 2 are equal. Therefore, we can see that the dA is exact. I can now proceed with step 2. I have to form two equations of f. No? Now, f from this, okay? So I take my f from the integral of m dx, okay, plus the unknown function in y, because y is considered a constant. What are the terms from m? Okay, we have this. We integrate partially with x, okay? So, tanan nga dili x adto before the integral sign. Or do not include that in the integration process, okay? Y squared is a pure constant term. So, you can only integrate the dx, okay? Minus 2y. So, you have an x left. So, integrate that one. Kine, this is x constant. X is the variable of integration. The constant 6 will be placed before the integral sign. Okay, proceed with integration. The integral of the dx is x. So, x times y squared, this one. Then, I have the integral of x dx, which is x squared over 2. Thus, I can eliminate my 2. And this is my second term. Okay? So, y with x squared or x squared times y. Then this one, square over 2. So, 3 over 2. That is why we have 3x squared. Now, since we treat our y as constant, the constant of integration will actually involve y. And that is the unknown function containing y. That is an answer if we know what is the unknown function y. So, we will be looking for this unknown function. Okay? I also have the other f from the second term, no? Okay. We integrate n dy, which is, kini, imula nang integrate diretso. And these are the terms of your coefficient of the dy. So that is to be subjected to integration with variable y. Okay. X squared is constant. We integrate only a dy. Then, kini, 2x is constant. I integrate y dy. And I have minus 2 constant. Then, what is left is the dy. So, subject this to integration. Y. So, x squared y. Negative x squared y. Kine, y squared over 2. So 2 is eliminated. So xy squared minus 2y plus the unknown function containing x because x are considered constant under partial integration process. So I have two possible answers or equations of f from 1 and 2. Okay, now, I'll be looking for the unknown function, g of y and the g of x. Now, if you have to consider terms, sir, pareho naman silang number of terms, tulo. Okay, I may consider a1 and I'll be collecting terms from a1. We have x squared, y squared, copy them all, and then try to identify this from the other equation. By the way, you notice, terms involving xy, okay, pareho na, asa man this one, pareho, common, no? So, that terms involving xy will actually appear common in every f, no? So, that means, this can also be used to check your work. Because if your xy term, no, does not exist common on f, no, it means there is something wrong as you solve, no? So, copy these three terms, then you look for a term purely y if any in A2. Do we have? Okay, so copying all the terms for my f, I have on saan xy squared minus, okay, x squared y, 3x squared, purely y. Okay, is there a purely y here? Then, consider that as part of your f. But your f is equal to c. So, all the terms are there, then you equate that to c. And that's your answer. Okay? xy term will not be duplicated. If you start here, copy all these terms, and consider a pure function in x, which can be found here also. Okay? So, that is your answer in number 1. Now, number 2. Okay, so these are the terms, no, in our given dA. I have to check for the exactness. My m is equal to 2xy tangent y. Differentiate this m with respect to y. This becomes 1, so 2x is left. What is the derivative of tangent? U. Kung tangent, that is secant squared u. Secant squared y. Okay? So, dapat my coefficient, my other coefficient will also produce the same result to consider our given as exact. N will be differentiated with x. X squared becomes 2x. Oh, that's 2x, na? X, derivative of which is 1. What is left is a secant squared or secant squared y, na? Okay, so the two are the same. Therefore, this is an exact differential equation. Okay, now, proceed finding f. Okay, from the first. Piyahala na? And then we can integrate with x partially. Then we have on saan, with respect to x, so x squared over 2. So what is left? X squared y. 2y is constant. So just think that the 2y is placed there. Then we have x dx. Okay? Okay, so tangent to y is constant. What's the integral of the dx? It is x. So x tangent y. Okay? Unknown function y is considered as constant. So it involves y. Okay? Possible answer for f or possible f. No? Oh, that's f1 from equation 1. Now, also, consider the secant terms. You integrate with y. Okay? So, we have this. Okay? Integral of x squared, y dy. Integral of x squared dy, I mean. So, x squared is there. You integrate a dy, it will produce y as the answer. Okay? So, there we have the integral of the first term. xy term. So, it must be present on both. Okay, that's correct. Na? Now, secant term. You integrate with respect to what variable? Y. Na? Okay, so, x is constant. What is the integral of secant squared u du? Diba, it's tangent du. So, we have the integral of that. So, we have x tangent y as your secant term. Now, if x tangent y is involving xy, so dapat those terms will be common on a1 and a2. We will be adding for a known function in x. Okay? Then f will be equal to c. Di ba? Okay, so unsa may atong f? Our f are the terms coming from this. Kini. I copy them. I'll be looking for purely y, but there's none. Okay, so meaning the g of y and the f of x does not exist. So your f is only this one. Okay? So, but your f is equal to c. So, from the term, sir, you equate that to c, and that is your answer. Okay? Now, the third, and this is the last. Okay? So, for the third, okay, so we have the cosine y, 2y, amen? Minus 3x squared y squared dx, then plus the cosine 2y minus 2x sine 2y minus 2x cubed y dy. Actually, this is being tested ganina for exactness, and we know that this is exact. And as a result, ganina, when it is tested, mao ni ato ang partial derivative with respect to y, the partial derivative with respect to x, so this is known to be exact. So I can now proceed with f. Okay? So we have an f, dire. So cosine 2y, 3x squared y squared, then we can consider an unknown function in y after integration. Okay, now, what is the integral of this with respect to x when the cosine 2y is constant? You integrate a dx. So that is why there is x cosine 2y. Integrating this with respect to x, so that is x cubed over 3. That is why we have x cubed y squared. Then that is the unknown function considered purely y, which can be sent out from your other f. This is a1. This is my a2. Okay? I integrate with respect to y, or partially with the variable y. Okay? Cosine 2y dy, actually kanan to that is inserted only in 1/2. Okay? So I will explain that later. The second term. So I have x sine 2y. 2 is included here because there is a role in sine u du form. Okay? So actually 2 is a constant but it is associated with dy. Okay? Then this one, 2x cubed, okay, is a constant. Then what is left is y when the variable of integration is y. Okay? Adding the unknown function f of x. Okay? What's the role when we integrate? If we have sine u, dapat there must be a du, an exact du. So, if your u is 2 times y, the du of which is 2 dy. That is why I did not put my 2 together with x. It's associated with dy because if 2 is placed here, then I need to insert another to unbalance with 1/2. Okay? So, ako na lang siyang gibutang daan, part of the differential because I know that this is 2y and it needs also 2 here to make it exact. Okay? For the same reason, if this is actually cosine 2y and dy, if this is my u, then I need 2 here to make it exact because I cannot apply any integration formula without having a u du form. Okay? So, if 2 is inserted, a neutralizing factor will be provided. No? So, we have that 1/2 because there is 2 inserted. 1/2 times 2 is 1. Na? What is the integral of a cosine u? The integral of which is sine u. So, 1/2 sine u and your u is 2y. Dire, what is the integral of sine? That is negative cosine. So, that makes the term as plus. Plus x cosine y. Kine, square over 2. So, 2 is out. So, x cubed y squared. Plus the unknown function in x. Now, asa may mas daghan og term ini? This is containing 2 terms. So, the unknown function, this is containing how many terms? 3. So, the answer here, ato na ko ibase from f having several terms. Na? Okay, so I can collect. Actually, this is the purely y. This is the xy. You can check with the other equation if that exists. Okay, xy also. So, the excess, common. Okay, then we have the unknown function in f. The unknown function in x, is not actually present in a1. So, meaning, the f of x is 0. So, which means, mao ra ni imuhang answer sa imong solution. This is your f and your f can now be equated to c. If you are going to base your answer from e1, so you collect all the terms. Okay, butang ni mo diha. Then you will be looking for this and that term is actually kini. Okay, so asay mas daghan og term, posible maunay mas kompleto. Okay, so muna yung nagsuwat. Okay, but anyway, you can start anywhere, either E1 or E2. Basta provide the unknown function when the exists on the other equation. Okay, so that's all for the exact differential equation. So, again, I'm inviting you to subscribe over my channel and thank you for following. Thank you for watching. And I hope I was able to give a little or more understanding with our lesson in exact differential equation. For now, bye-bye and good.